Okay guys, so today, or rather in this video, I'm going to walk you through a slight piece of code that is going to hopefully illustrate a way you can do integration testing for, your external dependencies or your external AJAX calls in JavaScript without having to do a lot of, not going crazy and having to do a lot of mocking and stubbing and stuff like that. So I'll just show you an example of what I usually see in projects, and hopefully this will resonate with you and you'll recognize this. So let's, for the sake of argument, say that hey, we have this project, and I'm just giving you a subset of the project right now where you have some type of this is very common. You have some API folder where all of the different calls to your server actually lives, where you're actually doing the AJAX calls themselves, and then usually what you have is some other abstraction like a service or something like that that consumes these APIs. And sometimes you don't even have a service, you just use the APIs themselves, the API module itself. So if we look at this file here for products, we see that okay, we're requiring fetch, and then we have an async function called getProduct, and all it does is it goes to my service product slash, yada yada yada, and then it returns the JSON response. Easy peasy. And then it exports this getProduct function. So now we have a way of getting our products. Now, what's wrong with this? Well, nothing really. This is absolutely fine from a usage perspective. It's very simple, in my opinion, fairly boilerplate, very standard, very very common. The issue comes when you want to test this, because since you're importing or requiring fetch inside of this file, that means that when you want to test this, unless you want to do the actual fetch call to an external service, you have no real way of switching out fetch for something else, because what you really want to do is to just avoid doing the actual network request, and you simply want to tell fetch somehow that hey, don't actually do the call, just fake the call and return some pre-programmed response that you yourself set in your test. Now there are tools that will do this for you, which I used to use a tool called Rewire. You can check out Rewire, it will help you with these cases. But this video is about showing you a different approach to solving this problem that doesn't actually require you to add more dependencies to your project. So let's look at users. So here, we'll walk through these in just a moment, but let's start at the top of this. So this API only exports a single function that takes in fetch as an input argument. And then it instantiates an object that has getUser and saveUser, and these have two functions. These are higher order functions, so basically they take in the fetch function. As we can see here, they take in the fetch function and they return an asynchronous function where fetch is now being used. This is equivalent to what you saw in the previous file, but the main difference here is that fetch is not imported in the file directly. It is a dependency of this module in order for it to work. So in other words, we are telling the caller of this module that, hey, I need fetch to work properly. Can you please provide fetch for me? And that's a big difference. This now has empowered, like fetch can be anything. The caller can now decide that, yeah, this is production code, so it's going to be the real fetch function. But let's go to our test code here. We are importing the API like this as an object, and then we just, do some sanity checks, and we'll do the first get user test. So we want to check that we can make a call. And I've created a mock JSON response that is going to, this is what's going to be the response, and then I have made a mock fetch function that I instantiate with that response. And that returns a function called fetch. So this is a fake fetch now. And the API is now, as we saw earlier, it's now being instantiated. So now, when I run this code, I actually get the fake fetch function is being called, and I can actually test this without having to use something like Rewire, and it doesn't do the network request. So I'm now in full control of what fetch is going to do. It can do anything I want it to. And for a testing perspective, this is actually very nice. The test is now going to be able to run, and I can test all the internal logic, and like I can do pretty much anything I want. And I think that this is a nicer way because I'm one of those people I like to keep my dependencies as few as possible because we have so many libraries and it often comes to a situation where you might find that there's an issue and so forth, and I think that if you can without a lot of work do your own thing to solve a problem like with your own code, you should try to do that if it's fairly clean. I'll just for sake of completeness show you mock fetch. So mock fetch, all it is a higher order function that takes in some response and then it returns a promise with that response. That's it. This is just a very simple example, but it works for our intended purposes. And the mock response is, as you may expect, a very simple function that returns an object that has a single property called JSON, and this is because as you may have you saw earlier probably, it's the case is that the response object that comes from fetch needs to have that function in order for it to work properly. So we're just faking a response object here, and that returns basically just a promise that has the data. So you can make something much fancier than this, but for this little demo of mine, this is just fine enough right now, right? So that's the first thing I wanted to show you. The second thing is that let's say that we had a service. Let's look at the user service here. So I have a user service where I want to be able to update a user's age. Now, services are also the type of, it's typical if you've been working in programming, like especially in object-oriented programming and styles and stuff. There's a lot of stubbing, there's a lot of mocking going on, and you basically have to do a lot of overhead work, in my experience, to be able to test the service effectively. But if you have this approach, it, in my opinion, gets a little bit easier. So this API, basically this module declares that it needs the API that this module as a dependency, and then it just exports a single object that has this function update user age, and then it has a higher order function that takes in the get user and the save user functions, and we'll just walk through the logic very quickly. So this higher order function is now instantiated with two functions that are asynchronous, that in production code these two are going to go to the network and actually get the user and actually save a user, but in a test environment I can declare they can do anything. I am in full control. This is basically the essence of dependency injection, and then we return an asynchronous function that expects a user ID and an age, and then we do a get user call and we get the user, and then we update the user with the new age, and then we save that user and return whatever that is going to return. And the elegance here is that I'm looking at this as just another way of doing dependency injection without having to use a tool like ReUI or anything like that. And if you start thinking about these impure functions as just data sources, and if you have the rule of thumb, your rule of thumb is that data sources, anything that is impure, I pass in as a dependency, because this is what I'm trying to achieve with this code. Your code becomes extremely testable very, very quickly. It might be, you might have to pass some stuff, and it's not perfect. I'm not saying it's perfect, but at least I think this is a nicer approach than having to stub and mock a bunch of stuff in your testing code. So to just illustrate how this works in a testing perspective, we import the user service module, and we also have sign-on here. I'll touch on that in just a moment. So the first thing we want to do is to update user age. So we set a user that has age 1, and now we declare the API object, and this can be anything. I mean, we're just faking the API object. We say get user and save user, and it's going to resolve to this user here, and then we have a function that is going to resolve to the same user. That's it. That's all it does. So user service is instantiated with the API object. We call it with a to, and we are expecting to get a user or an object back with age 2, and then we check for equality. Just to kind of prove to you that this works, I want to just run the test with just bam. As you can see, all my tests pass. So we have now stubbed away without a lot of work these internal impure functions that would regularly in common case or in production code go to the network. So our code became very testable very quickly. Now I want to show you one more example of this. This is a bit of a philosophical question, but I want don't kill me, philosophical isn't correctly spelled, but this is a little bit of like, this is called what I call a white box testing, and some people do this and some people don't, but I just wanted to show you how it works in the context of this demo of mine. So sometimes you may want to check that these internal service, like these network calls, are actually being made, and that they are being sometimes you actually want to check if they're being called the correct amount of times, and you want to check that they are sometimes called in a certain sequence. And that also becomes very easy when you have this approach. So Sign-in is an amazing library that allows you to stub and fake and mock and like do a lot of validation check on something like a function. And as you can see here, this is almost the same code. We use sign-in, we create a stub that is going to return this resolved promise with the user as we did earlier in the first test, and the same thing for the save user. And then we do the exact same thing. We instantiate our user service with this API. So now this has gotten these fake function as dependency injection. The service has the fake functions. We can call update user age, and because we don't actually need to update the age, because we're not interested in the age in this, or rather that the result of this function call is the correct one. We just want to check that these functions are called. So we're checking that did get user get called once, yes, and did save user get called once, yes, and then we just check that get user was called before save user. That's it. Easy peasy. Now these are trivial examples, but I hope they illustrate how powerful it can be if you think about network functions, like fetching stuff from a network or a database or a file, as impure functions or data sources that you simply pass into your pure code. And if you do that, things, at least in my experience, gets a little bit easier to test and to debug. And it becomes even, I would argue, a little bit more flexible. Hopefully this was useful to you, and I hope you have a great day.